Hello everyone. I want to go ahead and continue the second section of Module 1, Basics of Measurements, by talking about this idea of significant figures. One thing I will mention as we get started, this will be a bit of a longer segment than the first one. Feel free to pause and refresh to go back over anything that seems unclear. And feel free to stop and get practice partway through before moving on to the completion of the video. The learning objectives for this presentation are listed here. Record a measurement of either mass, length, or volume to the correct number of significant figures. Count the number of significant figures in any measurement. And the third one, perform calculations such as addition, subtraction, multiplication, or division on measured numbers and report an answer with the correct number of significant figures. To introduce this section of the textbook, the author discusses global temperature increase as a good way of introducing this idea of the importance of measurements. So the statement here is that the average global temperatures have increased by 0.6 degrees Celsius in the last century. So this is a fact, and we already know some things about this from last time. So we know that having this degrees Celsius here is important to know what units we have. If that were degrees Fahrenheit, it would be very different. If that were, say, nanokelvins, then we could almost ignore the issue altogether. Or if it were kilokelvins, then we probably wouldn't be here anymore. So the units are very important in determining what's going on. Also important, as we will see today, are the significant figures. So this is saying 0.6 degrees Celsius. It's not saying 0.58887, for example. So the fact that there is one digit here is telling us something. It's telling us that we know it is at least 0.5. We know it's gone up by at least that amount. But it hasn't gone up by more than 0.7. So the number of digits we're including here tells us a lot about what we know. So that's important to be aware of. And that's kind of what we're looking at as we get into significant figures. Many of you will be making measurements in your careers. This is important for consideration there as well. Okay, so we mentioned this last time. I want to reiterate it. This is a very important idea for this class. Every measurement has three parts: a number, a unit, and the significant figures. Today, of course, now we'll be talking about significant figures. Okay, so I want you to look at this brick, and I want you to think about how long you think it is. And when I look at it, I see it's between 1.5 and or between 1 and 1.5 centimeters, closer to 1.5 than 1. I'm going to say that it's 1.3 centimeters. You might think it's 1.4 centimeters. Neither one of those is incorrect. Those are both valid answers for how long is the brick. Let's look at this again with a different measuring tool. And I want you to take a minute and measure this and say how long you think it is. I think the brick is about 1.36 centimeters. So we know it's more than 1.3. We know it's less than 1.4, maybe a little bit closer to 1.4 than 1.3, or maybe it's midway between. If you said 1.35, that's probably fine. I think it's 1.36. Either way, we know more about the brick now than we did on the previous with the previous measuring device. What we're illustrating here is the idea of significant figures. The significant figures are telling us not just something about the object, but also about how we measured the properties of that object. So here we are, we're having a less certain measurement than we are over here based on the measuring device. When we report a measurement, we need to report all of the digits we know for sure, and an additional digit that's an uncertain digit or a guess. We're guessing that the last digit is a 6. Now that's better than not guessing. If we just put 1.3 or 1.4, that's not as good as putting 1.35 or 1.36. Okay, so when we report significant figures, we are always guessing the last digit, but the ones before it are not a guess. This is the best way to make a measurement. Okay, now what if we were making this measurement? I'm going to tell you that this line, I think it goes exactly onto this mark right here, and this mark is 4.5 centimeters. If we're guessing that, we know it's not 4.4, we know it's not 4.6. If we just wrote 4.5, that would be indicating that we're guessing it somewhere between 4.4 and 4.6. We're guessing that it is exactly on this mark as opposed to maybe right over here where it might be a 4.49 or right over here where it might be a 4.51. So we would report this number as 4.50. If you're guessing that it is exactly on a mark, that is the correct way to write that type of a measurement. When we make a measurement, we need to report all of the digits we know for sure, plus one that's a guess. And that is reporting not just about the object, but about the measuring tool. We will be doing most of the things where this will matter in terms of your performance in the class will occur during lab time. Okay, so you'll get a chance definitely in this week's lab and in further labs to make measurements with the correct number of significant figures. Okay, what I want to do now is I want to talk about other people's significant figures. So the idea here, when you make a measurement and you write down your measurement with the correct number of significant figures, is that someone else can come along and look at it and know what it means. This also means that you need to be able to look at what someone else has measured and know what their measurement means. So I want to go through a couple of guidelines for interpreting significant figures based on someone else's measurement. The first one is that all non-zero digits are always significant. So when we had the 1.36, each one of those was part of the measurement. They are all significant figures. There's no way to have a non-zero digit without it being part of a measurement. The second is that interior zeros are always significant. So if we had a number like 405 feet, for example, the 0 between the 4 and the 5 counts as if it were a significant figure. Leading zeros are never significant. When I say leading zeros, I'm referring to the zeros to the left of the first non-zero digit. Those are never significant. And the reason for that is because those zeros are not from an actual measurement. They are from simply being a placeholder. Those are placeholder zeros. So they are not significant. If we were to, for example, take let's say we had 2 kilometers and we wanted to convert that to, I'm sorry, I said that wrong. Let's say we had 2 meters and we wanted to convert that to kilometers. We would have 0.002 kilometers. That does not make the measurement more significant by just shifting the measuring units. Okay, so it's not an actual measurement if it's a leading zero. The trailing zeros are ambiguous. These are to the right of the last non-zero digit. So we're going to take a little bit of time to talk about these so we can know when they matter and when they don't. Okay, so trailing zeros. If there is a decimal point in the number, the trailing zero is significant. So if you include a decimal point in the measurement, you can count it as a significant figure. If there is not a decimal point in the number, the measurement is ambiguous. It is not clear about whether or not it is significant. If you have to interpret this sort of number, assume that those zeros are not significant at the end. If you need to report a number, use scientific notation to make it clear what you're reporting. Okay, so if you have zeros at the end, consider using scientific notation to make it very clear when those zeros matter. An example would be the 4.50 centimeters we looked at earlier. There was no reason to include that last zero other than because it was a significant figure. Okay, and so that's why we wrote it in that way. We'll get a bit of practice with this in just a minute. There's one more thing I want to talk about before that. This is the exact numbers. Exact numbers have an unlimited amount of significant figures. So how does that happen? If you're counting objects, if you're physically counting objects, the result of that is an exact number. I am currently wearing 2 shoes. I am not wearing 1.5 shoes. I'm not wearing 2.5 shoes. There's no ambiguity about the number of shoes I'm wearing. That is something that can be counted. Okay, so it's a discrete object. It has an unlimited amount of significant figures. Defined quantities will also have exact numbers in terms of significant figures. Unit conversions based on a definition are defined quantities. So, for example, when we say 1 kilometer equals 1,000 meters, that is a definition. That is an exact conversion. If you see an equation and there's a mathematical equation with a number in it, like a 2 or a 1/2, assume that those are exact numbers as well. And anytime you see a number without a unit, assume it's probably an exact number. Okay, so these are a couple of places where exact numbers come up. Okay, let's go ahead and get some practice. And the best way to do this is, I think, if you pause your video and then answer this question: how many significant figures in the following for each of these 6? Go ahead and do that, and then when you come back, I will tell you the answers. Okay, so here are the answers. So 234 inches, each of those is a non-zero digit, so that would be 3. 1.025 liters. There we're showing an interior 0, so that would be 4. Each one of those digits also counts as a significant figure. 4 tires is unlimited. That's physically counting objects, so there are unlimited significant figures there. Or you could write infinity if you like writing infinity. 0.003 seconds. Those leading zeros do not count, so it has 1 significant figure. 4.000 liters. Here we do show a decimal point, so the trailing zeros do count. That is 4 significant figures. There's no reason to include those trailing zeros except that they are significant figures. And then the last one, 1,000 yards. That is ambiguous, so we're going to call it 1. There are no decimal points shown there. We don't know if there's 4, 3, 2, or 1 significant figure, so we're just going to say that's 1 significant figure because it's ambiguous. I would recommend at this point getting a little bit more practice with this. If you look at the worksheet for this section, the first question provides more practice. So I would go ahead and do that before moving on to the rest of the video, because you need to be able to correctly assign significant figures in order to do calculations with significant figures. So make sure you understand this first before moving on to the rest of the video. Okay, so calculations with significant figures. We're going to look at how to round correctly when you do need to round, and then we're going to figure out when we round by looking at rules for calculations with multiplying and dividing and adding and subtracting. If you have a calculated answer that you need to round, we have 2 ways of doing this. We can either round up or we can round down. If the first digit you're dropping is 4 or less, then you would round down. Okay, so an example here, if you have the number 45.328 and you want that to be 3 significant figures, so we have 1, 2, 3, The last digit is a 2 that we're dropping, so we drop these off, drop the 2, 8, and we have 45.3. If the first digit you're dropping is 5 or greater, we round up. So here's an example. We have 2.4872. We want two significant figures for this number. So 1, 2 digits. The third digit is greater than 5. So we drop that, 872. We drop those 3 digits, and we round up to 2.5. Okay, so this is if you're rounding, how you decide what to do with the last digit as you round. You might have a case where you're rounding and you actually need more significant figures than your calculator is giving you. So if you have 4, if your calculator is telling you 4, you write that as 4.00. Be careful here, don't just put zeros on the end, don't change the number. So don't make it 400. So remember the decimal point. Okay, so some additional examples here. To get 3 significant figures. We sometimes might need to put digits at the end of our calculated answers in order to have the correct number of significant figures. When we multiply or divide significant numbers that have significant figures, we need to be able to report our answer with the correct number of significant figures. In order to do that, our answer has to have the same number of significant figures as whichever measurement had the fewest significant figures. Okay, so here's an example. We have 110.5, and we recognize this has 4 significant figures. And we have 0.048. We recognize this has 2 significant figures. If you're not sure why this is 4 and this is 2, I would recommend going back and watching the previous portion again and maybe getting some practice with this before going on. But we have 4 and 2, so we pick the smaller, which is 2, and we take the number from our calculator and we round it to whatever that was. So 2 in this case, we round this number to 2 significant figures. Okay, so when we multiply or divide, the answer to our calculation should have the same number of significant figures as whichever of our measurements had the fewest. When we add or subtract, we look at the decimal column. The decimal column determines the number of significant figures. Here is an example of that. We have 25.2 plus 1.34. 25.2 has 1 decimal place. 1.34 has 2 decimal places. So the one with the fewer decimal places is going to limit our answer. So when we do this calculation, we end up with 26.54, but we need to have only 1 decimal place, so we call this 26.5. When we add or subtract, we look at the decimal place to determine the number of significant figures. Sometimes you might have several operations that you need to perform. First thing is to perform these in the correct order. So if there's something in parentheses, you do that first, then you do multiplication, then you do addition. I should say multiplication or division second, so after parentheses, multiplication or division, and then last you do addition or subtraction. For intermediate steps, determine the number of significant figures. So if you have, for example, in parentheses an addition or subtraction, figure out those significant figures before you do the next calculation. When you determine the final significant figures, remember to include those intermediate steps. You'll get a little bit of practice with this today, but we'll see more of this as we proceed into next week. When you do calculations with units, you need to also know how the units interact as the calculation takes place. When you are adding or subtracting measured numbers, you can only add or subtract if the units are exactly the same. Okay, the units have to match. You can't add apples and oranges, you can only add apples and apples. When you multiply or divide, you add up those units. So technically you could multiply apples by oranges. It doesn't necessarily mean anything physically, but the units would then be apple oranges. When you are dividing, you would subtract units if possible. So for example, if you had square centimeters divided by centimeters, you would subtract and have the 2 from the square minus the 1 and end up with just centimeters. Okay, we'll spend more on the time on this again in the next segment. But you will see some examples of that on the worksheet you're about to look at. Okay, so that is the end of the second segment of this module. We did cover a lot. Feel free to go back and rewatch some of this if you need to. Make sure to complete worksheet 2.2 before proceeding on to section 2.3. If you have questions, feel free to put them on the discussion board. Feel free to engage with other students on the discussion board related to this worksheet.